So we did simplifying a single one. We multiplied them and just really kind of turned them into a single one. Today we're going to divide. Now remember, with dividing radicals, that's where rationalizing and all of that always comes in. Okay? So let's start with just dividing, not rationalizing right away. So same rules before. I can multiply them as long as the index is the same. Cubed roots, multiply cubed roots. Same idea with dividing. Okay, they're both cubed roots, which means I can actually divide these if they divide nice. Can I do 189 divided by 7? What's 189 divided by 7? 27. All right, so that's going to be the cubed root of 27. And then x to the 7th over x squared. X to the 5th. By default, where do they go? By default, they go to the top. So x to the 5th. Or you can think of it like last chapter when you're like, all right, I'm going to cancel this and turn that into a 5, and I can divide this by 7, divide this by 7. Right, last chapter we did all that crossing off and simplifying. So really look what happened to the bottom. It's gone. So all I have left is the cubed root of 27x to the 5th. Okay? Cubed root of 27? That's just 3. How many groups of 3 can I take from the x's? 1 group. How many would be left over? There'd be 2 left over. And we are done. Now that one, not bad because it actually divided nice and pretty. Okay? All right, number 2. It's the 4th root. So 243 over 3. Can I simplify that some? I can divide them both by 3. So that's just a 1. And then this one becomes 81. And my x's, I can cancel these 3, and this would become x to the 4th. So just rewriting, because that looks like a hot mess. I have the 4th root of 81, and I have the 4th root of x to the 4th. All right, just kind of cleaning up, just like last chapter, canceling stuff out, simplifying it. What's the 4th root of 81? That's 3. And how many groups of 4 can you take from the x's? Just 1, and there's none left over. So that's just 3 over x. So the big thing with dividing is you want to make sure you divide or simplify your fractions first. Okay? Make sure you do that first. So number 3. Can I divide or simplify 63 and 7? Yeah? So 7 cancels and 63 becomes a 9. And then what else? The y? The y cancels and this becomes y squared. So on the top I have a 9xy squared, and on the bottom, nothing. I don't have to worry about anything down there. So what's my index number? 2. Can I do the square root of 9? That's 3. Can I take a group of 2 from the x's? Nope, so he stays inside. Group of 2 from the y's? Yep. Any leftovers? Oh. So I'm done. Make sure you divide or simplify first. When you don't is when these problems become a hot mess. All right, so number 4. 54 and 2? What's 54 become? X's. Cancel 2 of them out. So this becomes x to the 3rd. I can cancel that y. That becomes y squared. So on top I have a 27, an x cubed, and a y squared. And on the bottom, nothing. Index number? 2. Square root of 27? I can't, so what should I do? Factor 3. How many do I need in a group in order to come out? I need 2. So I have 2 3s. So that 3 comes out. Leftovers go in the fridge. So that 3 goes back in. How many groups of 2 from the x's? 1 group. Any leftovers? Groups of 2 from the y's? Leftovers? How are we doing so far? The part, as long as you divide or simplify it first, they're not as bad. Rationalizing still is a little kind of wrap your head around, but it's not terrible. But if you don't simplify first, they become really ugly really fast. All right, number 5. 162 and 6. Can I simplify those? Do they divide nice? Yeah, what do they divide to? 27? So that one's gone. This becomes a 27. And the x's? Cancel the 1 from the top, and this one becomes a squared. So I have a radical 27 on top and a radical x squared on the bottom. All right, remember my little index number is a 2. So square root, it's going to be 3 radical 3. We just did that on the last one, right? And on the bottom, just x. All right, number 6, 108 and 2. You can divide those. So 108 becomes 54. And that's it. So I'm going to go ahead and rewrite it. So I get the cubed root of 54y over the cubed root of x to the 6th. Now, did you notice what else I did when I rewrote that? What did I do with that radical? I separated it. Remember, we kind of try to ingrain that in you from the beginning of the semester when we first did these. You want to always write them split so you don't forget that they're both underneath that radical. So cubed root of 54. It's not perfect. Okay, so we'll do our factor tree on it. How many do I need in a group in order to come out? I need 3 in a group because my index is a 3. So 1, 2, 3. So 3 comes out. Leftovers go in the fridge. So 2 is inside. Can I take a group of 3 from the y? So what happens to the y? He stays inside. Then on the bottom, that's just x squared. And I'm done. That's the basics. Simplify first, and then just go ahead and use your radicals and simplify from there. Questions before we move on to where we're going to have to rationalize? Okay. All right. Did I skip a slide? There it is. I jumped. All right. So rationalizing the denominator. This is, how did we normally rationalize? If I had a radical 3 on the bottom, what did you do? You multiply top and bottom by that radical 3. Why? To get rid of it, right? Because what was the index on a radical, just a regular radical? The index is a 2. So if I already had a radical 3 and you put another radical 3, how many did you have? You had 2. So if I have an index of 3, I need there to be 3 of them. Yeah. So a simplified answer does not have a radical in the denominator. To eliminate the radical, blank the top and bottom of the fraction by the same radical. Multiply. So all of these rules seem very similar. It's just on what we multiply by that's different. The radical used to rationalize should have enough bases to make an exponent so that the power and the root cancel each other. In other words, if it's a cubed root, I want 3. If it's a fourth root, I want 4. They should be the same so that they cancel each other out. Okay? Let's go. Let's try this. So step by step, let's kind of write some steps up maybe right away. Step 1, when we're dealing with a division, I want you to simplify your fractions. Have to simplify first, guys. Some of you get so excited to like rationalize. Remember we did this before. You're like, ooh, I'm going to rationalize right away. And really, if you'd have simplified it, you wouldn't have even needed to rationalize. So simplify first. Factor trees. Hopefully self-sufficient, right? Try your factor trees to simplify those radicals. Then if you need to rationalize, you will do that next. Rationalize denominator. And then last, you'll try to simplify anything else that possibly might need simplified. But you don't simplify first, these get really ugly. All right, so if I have 3 over the square root of 5, does that look familiar from what we've done in the past? Yeah. Okay, so normally you'd be like, oh yeah, I just multiply top and bottom by radical 5, which is true, but I want you to understand why you're doing that. Right now, this index is a 2. What's the exponent on that 5? That's 1. That's 5 to the first. And 5 to the first makes 5 squared. Right? Just hang with me here, thinking through this. That gives you the square root of 5 squared. You guys agree? 1 5 here, 1 5 there. I have now 2 5s. How many groups of 2 could you take from your 5s? 1 group, so you tell me it was just 5. You want that index number and that exponent to be the same. That way I can take just the 1 group out and it's just a beautiful 5 left sitting there. And then on the top, that's just 3 radical 5. Okay, so I want whatever the index is, I want to make sure I give myself enough pieces so that I have exactly the same number, so they match. That way they cancel each other out. So if I look at the next one, going through my steps, I don't want you to forget these. Can I simplify the fraction? Can I 3 and a 2, can I simplify those? Nope. Can I do any factor trees? Nope. So then I'm at rationalize. This is 2 to the first. How many 2's do I need all together? I need there to be 3. So how many more 2's do I need? I need 2 more 2's. I need 2 squared. Right, I already had 1, 2 to the first. I need there to be 3 altogether, so I needed 2 more. That makes sense. It's not here where I can just like, oh yeah, whatever it is, I just multiply it, because it's not going to give me enough for that radical to go away. So now, what did you just create on the bottom? You created the cubed root of 2 cubed, which is just 2. And on the top? No. Yes. It'd be the cubed root of 12. Because 2 squared is 4 times 3 is 12. That's just the cubed root of 12. Yeah, your order of operations say that you do exponents before you multiply. All right, PEMDAS, you guys know that? Yeah, so when you're dealing with numbers like that, you want to actually tell me what the number is. So 2 squared is 4, and then times that 3. All right, number 9. So simplify my fractions. I can't. Factor tree, can I take a group of 5 from those x's? No. Rationalize denominator. So I multiply by the 5th root of what? How many more x's do I need? I need 3 more. Good. I already have 2. If I get 3 more, that now has given me, I've created the 5th root of x to the 5th on the bottom. Right? I gave myself 5 total x's. And the 5th root of x to the 5th is just x. And on the top, that's just going to be 6 times the 5th root of x cubed. How are we doing so far? Like we just focused on rationalizing. So it makes sense. Whatever the index number is, that's how many I want. So number 10. Can I simplify my fraction, 5 over 4? No. But do you notice it's got a big tall radical on it? Yeah, let's split that. So I have the cubed root of 5 over the cubed root of 4. All right, if I do a factor tree, I don't get enough pairs that I can actually do anything with. Now, There's two ways you can do this. We can do it the easy way, or we can do it the hard way. Some of you are going to choose the hard way every time, and it's going to blow my mind. Some of you always will. On the bottom, right now I have 4 to the first, right? So I would need how many more 4s? I would need 2 more. And you can do that. I can multiply top and bottom by the cubed root of 4 squared. I can give me 2 more. But then I'd have a lot more simplifying to do at the end. How else can you rewrite 4? That's 2 squared. I didn't change the value. Because now instead of needing 4 squared, I only need 1 more 2. Right? Crazy. So if you get a number like 4 that I can rewrite as 2 squared, rewrite it. If I gave you 25, you would rewrite that as 5 squared. If I gave you 27, you rewrite that as 3 cubed. 3 cubed. Yeah, 3 cubed. Now, chances are I'm going to give you some numbers that you're probably going to recognize. If I gave you an 8, yeah, what's that? That's 2 cubed. 8 is 2 cubed. If you're not sure, if you do a factor tree, would you find out what it is? Yeah, factor tree, right? If I did a factor tree on 4, it'd be 2 and 2. 2 squared. I have 2 2's. All right, this is the easy way. If I can make my number smaller, do it. So I have to multiply top and bottom now by what? Just 2. Because I already have 2 2's, I only need 1 more to make 3. So what's my denominator going to be? Just 2. And on the top? Good. Cubed root of 10. Let me show you the hard way. Don't write it down. You don't have to write it the hard way down. But let me show you the difference. Because this wasn't so bad, right? Like, it wasn't bad. If you went the hard route, which I know some of you will, cubed root of 5 over cubed root of 4. Let's say I did not change that 4. So that means I would need to multiply by how many more 4's? 2 more. Which I can totally do that. So what's that make on the bottom? That would make it just a 4. On the top, I now have the cubed root of 4 squared is, and 16 times 5. Is that 80? And then I'd have to do a factor tree on this. So then I'm looking for groups of 3. So 1, 2, 3. So a 2 comes out. I'd have a leftover 10. And then I'd have to be like, oh yeah, I can simplify 2. I can simplify that with that 4. I could, no, because somebody's like, what's wrong with you? Can I still get there the hard way? Yes. Chances are, what's going to happen? You're going to get through here, and you're going to stop here and never give it another look. And you're going to lose a lot of points because you didn't keep simplifying. Go the easy route. Just if you can change the base number to something smaller, change your base. A lot faster. So on number 11, what would you change? How would you change the 9? Nine is 3 squared. Change the base to something smaller, it's going to be easier. So instead of needing to multiply top and bottom by 9 squared, which is 81, I only have to multiply it by 3. Cubed root of 3. So much nicer. So on the top, we get 3 times the cubed root of 3. What's the bottom? That's just 3. Am I done? Yeah, 3 over 3 is going to cancel. So really my answer is just the cubed root of 3. Again, you can go the hard route. Your numbers get way bigger and a lot more complex, a lot more simplifying. Yeah. Number 12. Can I simplify my fraction first? Okay, I can change that. But is there any like fractions I can cancel things out? Can I do any factor trees on anything? Can I take any groups of 3 from anything? No? Okay. Always look for that first, though. But we can rewrite that as the cubed root of x squared over the cubed root 5 squared y squared z. All right, so changing 25 to 5 squared. It's going to help us out. So I am at the point where I need to rationalize. You have a lot of things down here. How many more 5s do I need? One more. How many more y's? One more. How many more z's? Two more. So I have to multiply top and bottom by 5yz squared. Anybody not understand where I just got all that from? I want 3 of everything. What did you just create on the bottom? Siri, what's the bottom going to be? Don't sleep on me. Just totally watch his whole head fall asleep and his head drop. Yes. I've now created 3 5s, 3 y's, 3 z's, so the cubed root of all of those is just 5yz. And then the top is I just really like alphabetical order. Order really doesn't matter, but mine always be alphabetical. So yeah, I'm just they're both underneath cubed root, so I'm just going to multiply them together, and I'm done. As long as you simplify first, they're not terrible. But if you don't, can you imagine multiplying top and bottom by 25 squared? Let's not. I am a lazy mathematician. That is way more work than I want to do, because then you're going to have to do a big factor tree on that whole thing. It's ugly. All right, 13. What do I do first? I divide. Remember, step 1 is to divide or simplify your fraction. So 2 and 54, I can divide those. 54 becomes 27. What about the x's? Cancel the 5 on top, and I get just x on the bottom. Good. So let me rewrite so I can actually read that. So I have a 27y squared on the top, and the bottom is just an x. Okay. Can I take a group of 3 from anything? That was step 2. I said to do your factor trees. 27. Good. The cubed root of 27 is just 3. Can I take a group of 3 from the y's? From the x's? No. Okay, so those are going to stay underneath my radicals. All right, so I did step 1, I did step 2. Step 3, rationalize. I have to multiply top and bottom by what? The cubed root of x squared. Don't forget the cubed root over top of it. Right, I already had 1x, I just needed 2 more. So on the top, we have 3 times the cubed root of x squared y squared. And on the bottom, what do we have? Just x. Because again, you created the cubed root of x cubed, which is just x. That's what you created. I can't tell if we were having an amazing day and we got this and we're awesome, or if we just don't have any idea what's going on. Ruben, how you doing? You're kind of dying? Okay. All right. Try number 14 on your own. We will. 14 on your own. All right, guys, let's go through 14, see how we did. So first thing is to simplify your fractions. So 5 and 2, I can't do anything, but the x's, I can cancel this one. This is just an x squared. Cancel both of these y's and just a y down here. So I have the 4th root of 5x squared over the 4th root of 2y. That should have been your first step. Okay? Then I look for, can I do a factor tree or take any groups of 4 out? Anything there? Yes? No? Talk to me. No, I cannot. Good. Then I'm at rationalize. I can't change 2 to a smaller base, right? Like 4, I wrote as 2 squared. I can't change that one. So I need to multiply top and bottom by the 4th root of, how many more 2's do I need? I need 3 more. How many more y's do I need? 3 more. So 2 cubed y cubed. What do I get on the bottom? Just 2y. Because you have created 2 to the 4th and y to the 4th, right? I now have 4 of each. And if I do the 4th root of those, they just cancel each other out. On the top, I have the 4th root. 2 cubed is 8 times 5, 40. Then I have an x squared and a y cubed. Now your last step says to simplify. Some of you got to that point and were like, I feel like I should simplify this. Can I take the 40 and divide it by 2? This one's under a radical, this one's not. So I can't actually divide those. If I did a factor tree on 40, you'd only have 3 2's. I had 3 right there. Right? I'd only have 3 2's, not 4, so I can't actually take anything out. So this is as far as it goes. This takes practice. It's a matter of you really got to sit down, work through it, and practice it. Okay?